So here today I will talk about PCA, K-means clustering and perceptron, and discuss some of the probable true-false questions or short questions that will help you in your midterm exams. Okay, and the day after tomorrow, on Friday, Nebev will come and he will discuss other topics like neural networks and LDA, logistic regression. He will cover those topics and he will also discuss some of the probable questions that will help you solve your question on midterm. So today, we will try to make this session interactive. So I will ask the question and audience will answer, like whoever raised their hand first. And we will discuss why this is true, why this is false, why we are solving it in this way, and things like that. So let's start with true false. The very first question. Data overfitting can be avoided by increasing the complexity of the model. Is it true or is it false? Who wants to answer? Raise your hand. Yes.
Is this one posted or no?
Sorry?
Is this posted on Piazza or no?
No. This will not be posted on Piazza and we will not share the answers and everything. Yeah.
They always go avoid by increasing the complexity of the model. I just say false, and I don't really have a great proof. I just think that sounds like a stupid statement. That's all.
Okay.
False, because if you increase the complexity, it solves tons of things. But increasing if you're increasing the complexity, it actually increases the risk of overfitting.
Right. So yes, if the model is already overfitting, it indicates that your model is already sufficiently complex or more complex than you need, right? So to reduce overfit or to avoid overfitting, you need to reduce the complexity of the model, right? Not increase it. Second one, K-means clustering always provides balanced cluster. Balanced cluster means if you have a number of points and you have like n cluster, K-means will always assign same number of points to each cluster. What do you think about this question? Yes. False. Why?
Always give you the same amount in each cluster.
Okay. Anyone else? So this is false, yes, and your statement is true. Like, let's say we have 3 points and 2 clusters, right? We cannot assign same number of points in each cluster. So this can be an example. Like, you can either say that it doesn't assign same number of points in each cluster, or you can say that if you have like 3 points and 2 clusters, we can never assign same number of points in each cluster. Third question. A single layer network means a perceptron, can learn nonlinear decision boundaries with a sign activation function. Sign activation is basically you take the sign of the output of the equation, whether it is a positive or a negative, right? So what is the answer for this question? Let's see if anyone else raised their hand. Anyone else? Yes.
False, because sign returns a binary classification.
Okay. Yes. Okay. Anyone else? Yes.
The perception of the linear function can be used to describe a non-linear only.
Okay. Okay. That's good. Anyone else? So we have 2 candidates for explanation. One is saying perceptron provides us binary classification. Another is saying perceptron is always linear. Which one do we vote for? Second? Okay. Any other choice? Yes.
I was gonna say second.
Second one. Okay. Okay. So first thing is that we will talk about whether perceptron can learn non-linear things later, but right now, yeah, this is false. Because when you take the sign of the output, it is always binary, either positive or negative, right? So there are two sides and this is always linear. That's it. Your decision boundary will be on the 0 point, 0 line, and positive and negative on either side. Now, which statement is correct? Let's go to the next question. A perceptron can learn non-linear decision boundary with a squared activation function. So the difference between this question and this question is this. The activation function is different. It is still single layer, but the activation function is different, right? Now what do you think? Yes? So is this true or false? True. Okay. Someone is saying it is true. What about others? Yes.
It's true because that just looks nonlinear, the squared.
Oh. Great explanation. Yes.
Yeah.
Good. Anyone else? So this is true because it looks non-linear, right? So basically, whether a classifier can provide non-linear decision boundary or not depends on the activation function we use, right? So if your activation function is linear, the decision boundary will be linear. For example, the sine activation function is always linear. There are two sides and a straight line. But this squared activation function, this is non-linear, right? So if you use a non-linear decision boundary, your decision boundary, if you use a non-linear activation function, your decision boundary will be non-linear. And that is the thing we do in neural networks, right? We use all kind of non-linear activation functions like sigmoid or ReLU or kind of things. So yes, perceptron does not always provide you a linear decision boundary. It depends on the activation function you use. If you use a linear activation function like the sine function, it will be a linear decision boundary. But if you use like quadratic activation function or non-linear activation function like a squared activation function, perceptron can provide you non-linear decision boundaries. Okay? Good? Yes? Sorry, I didn't get your question. If you take the sine of the squared function, will that no, that will not give you a non-linear decision boundary because the equation itself is linear, right? So as long as your equation is linear, it will give you linear decision boundary. So if you remove the sine from the equation on 3, it will be wx plus b. It is a linear equation, right? So it will give you linear decision boundary. Okay? So if your equation is linear, it will give you linear decision boundary. If your equation is quadratic or non-linear, then it will give you non-linear decision boundary. So whenever you are answering questions, don't focus on the perceptron part. Focus on the activation function part. Okay?
Can you say that again, please?
So whenever we are doing neural networks or perceptron or whatever classifier, if your activation function is non-linear, that will give you non-linear decision boundary. Okay? Okay, let's move on. Question 5. A model is giving a small error on training data, large error on validation data. That means the model is underfitting, right? Yes. False. Why? That represents overfitting. If you get high accuracy or low error in training data, that is overfitting. Question 6. To reduce the bias in a model, we can add, yes, 5 false. It is overfitting. Question 6. To reduce the bias in a model, we can add more training samples. So if your model has high bias, we can reduce the bias by adding more training samples. Is it true or false? Let's look for something else. Anyone? Please. No? Yes.
Is it false?
Because
I think it has to do with the training examples that are independent.
independent of
The test,
training cell is always independent. Thank you. Anyone else? Yes.
Shouldn't it just depend on the type of training examples? Because if you add training examples that contain the same bias, your model will produce output similar with that bias.
So bias has little to do with training examples. That is the part. So bias means the model is basically not learning anything. It is just predicting some garbage thing, right? So bias happens when your model is too simple. It doesn't have enough or sufficient parameters to learn or like model the data. If your model is too simple that cannot model the data, for example, if you have a quadratic data, right, spiral data or something in higher dimension space, and you are using a linear system that cannot do sufficient classification, that cannot provide you sufficient accuracy. So your model is too simple. Whether you increase the training data or decrease the test data, whatever you do, your model cannot learn anything. That is bias. Okay. So bias is model is simple, it cannot learn anything. So if you want to mitigate bias, increase the model complexity. Choose a suitable model that can model your data. Okay. If your model is overfitting, reduce the complexity of the model. Okay. And to reduce overfitting, you can do two things: add regularization, like add regularization to the loss term, to the model weights, or reduce the complexity of the model. Okay, clear? Bias and variance. Bias means your model is too simple, and overfitting means your model is too complex. Question 7. K-means class.
Sorry, I have a question. So, in question 6, when they talk about reducing bias, so they're talking about something different than the B term in WX plus B.
They are talking about the B term,
Oh, they are talking about the B term. Okay.
but B term will only increase to significantly higher number if your W term is not sufficient.
If
Right.
your what term isn't sufficient?
W weight term is not sufficient.
Okay.
Right? Yes.
So ultimately with bias, it's always, and variance, it's always just a problem of the model itself and not the amount of training examples.
The amount of training example is important, of course. If you have like very few training examples, then the model can overfit.
Okay.
That is there, but the initial problem is with the model. If you have sufficient training example, then it is probably with the model.
Okay.
If you have very limited training example, any model will overfit. Any model.
Okay.
Yes.
Oh, I just wanted to confirm it's false, right?
Okay, question 7. K-means clustering solves a convex optimization problem that always converges to the same solution. That means if you run K-means multiple times on same data, it will always provide you the same result or same cluster assignments. Is this question clear? So we have some data. Let's say 4 data, right? X1, X2, X3 and X4. And we have 2 clusters. So no matter how many times we run K-means on this 4 sample, sample 1 and 2 always go to cluster 1 and sample 3 and 4 always goes to cluster 2. Is this true? Like no matter how many times you run K-means clustering, it will always return you the same result.
Yes.
Yes. Yeah, you can randomize where you want to start. That is there. But let's say we give you the freedom. Start from anywhere, in any run. Will it always return the same result? Yes. For example, run 1. You start from somewhere. You put your centroid anywhere, run it, it gives you a result, right? In second run, you take your centroid from anywhere, run it, and get your result. Will that be safe? That is the question. Yes. Convex problem has a global optimum. Okay. Anyone else? Yes.
False because we centers are random every time.
Okay.
They change.
So we will get true and false. Okay. Anyone else? Let's see. Yes.
Makes sense, I would say false.
Because
Well. I have the answer.
okay. So this is false. Yes.
Is one case is if there's an outlier. So if one of your categories is an outlier, then the rest of the data will just go to one category.
No, actually. So basically, if you run k-means multiple times, it will give you different results. That is the part. Because the centroids are initialized at different places, at different runs. So for example, let me show you a quick example. Can be like this. Let's say we have these 4 points, right? That we want to cluster in two different clusters. Now, if we start for run 1, we start from our first centroid at here and second centroid at here, right? This is our run 1. We initialize the centroid here. That will give you one cluster here and another cluster here. Okay? But on second run, if you initialize the centroid here, one centroid here and one centroid here, that will give you this assignment. Okay? So based on your centroid assignment, you can get totally different result. And if you like initialize the centroid like here, you see, far away from your data, then all the points will be on a single cluster, right? So it depends on your initialization. Yes.
My previous answer would be, since k-means clustering is not a deterministic model, we can't always remember this. Would that be a good answer?
That will be a good answer. Any confusion on this? No? Okay, let's move on. We will move a bit quickly because we have to solve a lot of questions. 8. Principal component captures direction of the largest variance in the data. Who else? Anyone else?
True.
Raise your hand, please. Yes. True. Why?
Because it captures the direction along which the most data is.
This is the definition of PCA, right? So it captures the largest variance. Yes, true. Question 9. PCA finds a new set of features that are linear combination of the original features. True or false? Yes. True. Why?
PCA uses
Yes. So PCA will find correlated features and combine them to get the new one, right? So it is the combination of the old feature to get the new feature. So this is true. Question 10. PCA requires that all features be normally distributed. Who wants to answer this one? Like if you want to do PCA, your data points or the values you have or the vectors you have needs to be normally distributed. needs to be from a normal distribution or Gaussian distribution. Yes. True? Yes. Why?
Because in PCA you subtract the mean from each of the data point, which normalizes the data around the center.
Subtracting mean does not normalize the data. It takes the data to the center,
Yeah, so which is nearly
which is not
Gaussian.
normal distribution. Normal distribution is a different thing. Subtracting mean is basically taking the data, shifting it. That's it. It does not change the distribution you have. It is just shifting things away. But the data itself has the same distribution. Anyone? No. So PCA does not require normal distribution. You center the data, that is for different reasons, that makes your calculation easy. But it does not assume that your data is from Gaussian or normal distribution or whatever distribution. What your data can come from any distribution. Okay? So you can apply PCA in any data. It does not have to be normally distributed. So this is false. 11. The perceptron updates its weight using a gradient descent method. Yes. It's true. Okay. Anyone else? Okay, anybody thinks this is false? You?
I was gonna say the use is maybe a normal.
You're not sure about how to name the function, right? But it is not gradient descent. Okay. So everybody else is true? Like everybody else thinks that PCA uses gradient descent? Okay, let's see how many of you thinks this is true, like perceptron uses gradient descent. True? Yes. Okay. 1 true, 2 true, 3, 4. What about the others? Okay, I see a bunch of truths, false. And who thinks this is a garbage question? This question should not exist in the world. So, interesting part is PCA does not use gradient descent. Gradient descents are, yes.
You mean
Perceptron, sorry. Perceptron does not use gradient descent. Perceptron use a rule-based method. If a sample it picks is wrongly classified, it updates the weight towards that direction so that it can classify that sample properly. It is nothing to do with gradient descent because we do not compute any loss for perceptron. We just pick a sample, see if it is classified correctly or not. If it is not correctly classified, then we update the weight. We do not calculate any loss there. If there is no loss, there is no gradient descent. Okay? So neural networks in general uses gradient descent, but perceptrons do not use gradient descent. Okay? Do not be confused. Last
So,
question.
Wait.
Yeah.
So gradient descent is used for logistic regression, but not for just a linear perceptron. Okay.
Question 12. A single perceptron can be used to classify data into multiple classes. Who thinks this is false? Yes. What do you think?
False.
False. What do you think? Let's pick a random person. Should I? No, this is false because a single perceptron can give you like binary classification, like left or right, 0 or 1, 1 or minus 1, whatever you can think of. Binary classification. So single perceptron gives you binary classification. If you want to do multi-class classification, you can have multiple perceptrons, right? So that's it for true false. Any confusion? No? Okay, let's move on to the fun part. Short question. So this question is on K-means clustering. Okay. So we are given a number. Yes. No, 2 means binary. Multiple means more than 2. No, multiple, when you say multiple, then this means more than 2. 3 and above. So this is from clustering. We have 4 data points and we need to cluster it into 2 different clusters, okay? So you are given the data points and the initial position of the centers. Okay? We have 3 questions. Upon convergence, what are the centroids that you will get? So if you run clustering, if you run K-means clustering on this data, you get the result, your final result, what is the value for mu1 and mu2, okay? The second question is, which points are assigned to cluster 1 and which points are assigned to cluster 2, okay? Any confusion with the question? Is the question clear? So let's solve this by plotting the points. We have 1, 1. So we have plotted the points, okay? We have 4 points, x1, x2, x3 and x4, and we have 2 centroids, mu1 and mu2, right? Now we need to apply K-means clustering on this part. So whenever you are answering this kind of question, like you are calculating some kind of distance or similarity, read the question carefully. Because the immediate thing that we think of when see distance is L2 distance or Euclidean distance. That is hard to calculate. So we are asking you to calculate L1 distance, not L2 distance. So in midterm 1, we asked you to either use L1 distance or a squared L2 distance. That does not require you to calculate the square roots. Okay? So read the question carefully, whether we asked you to use L1 or L2 or a squared L2, whatever. Because based on the distance you use, you can get very different results. Is that part clear? So read the question carefully. If there are some kind of distance, we specify which distance you need to make, you need to use. So we are using L1 distance. So if you calculate the distance between x1 and mu1, they're the same point, right? There is no distance. If you calculate the distance between x2 and mu1, so it is L1 distance, right? L1 is basically this one, 1 minus 1 plus 1 minus 0. That will give you 1, right? You need to calculate distance for each of the points. And x4 basically 1 minus 1. So we got 4 distances for each of the points from mu1, right? But we need to also calculate the distance from mu2, otherwise we cannot decide, right? So we need to do this for mu2. distance of x1 from mu2 would be 1 minus 1 distance of x2 from mu2 0 minus minus 1 1 plus minus 1 sorry 1 plus 4 plus 3 distance of x3 mu2 is 3 distance of x4 mu2 is 0. So let me write things clearly so that it is easier to read. So for x1, if we calculate the distance between x1 and mu1, it is 0, right? And if we calculate the distance between x1 and mu2, this is 4. So x1 should be classified to cluster 1, right? It is closer. So it goes to cluster 1. Let's call it mu1. It goes here. For x2, we need to calculate the distance from mu1. So this is the distance. We get 1. And we need to calculate distance from mu2. This is this one, which is 3, right? So again, mu1 is closer to this point. So this goes to mu1. For x3, we need to calculate distance from mu1. This is this one, 1. And x3 from mu2, this is this one. This gives you 3. So it again goes to mu1, right? For x4, distance from mu1 is 4. This one. This 4. And distance from mu2 is 0. So this point goes to mu2. Okay? So 3 samples, first 3, x1, x2, x3 goes to mu1 and the fourth sample goes to mu2. Okay? So we have our answer for second and third question. Which points assigned to cluster 1? They are x1, x2, x3. And which point belongs to cluster 2? x4, right? Now first question is still there. What is the updated value of mu1 and mu2, right? So once you do a single iteration on the data, you need to update the centroids. To update the centroids, it is basically averaging the points, okay? So for mu2, it is straightforward. It has only 1 point. So mu2 will be basically x4, whatever we have there. So that is basically -1, -1. That's it. For mu1, we have to average things. We have 3 points in mu1. So we take 1/3 over x1 plus x2 plus x3, right? So it would be 1/3. We have 1, 1. We have 1, 0, and we have 0, 1. So it will be 1/3 of 2, 2. This is the updated mu1. Any question on this question? Yes.
So you just take all the points classified between mu1 and mu2, and then you take the mean, and then that's your updated value.
Yes. So, any question? Any confusion? So for k means, yes.
So if we're gonna do a iteration.
Yeah. So whenever you use the second iteration, you use the updated ones. So whenever you are doing k-means clustering, you have to remember 2 things. Start with some point, do the clustering. Like run through all the samples, get the assignment. So this point goes to cluster 1, this point goes to cluster 2, right? Once you are done with all the samples, then you have to take the averages of the samples. And that will be your new centroid. So here, our new centroid for mu1 is basically 1/3 of 2 vector. Okay. On second iteration, you have to use these centroids to calculate the cluster assignment. Okay. Now, the question is, do we need a second iteration here? It seems like everything is clustered properly. It seems like, but we cannot guarantee it. So when can we guarantee it? So if you are doing one iteration of k-means, and after that iteration you have updated your mu's, like you get new centroids, then that does not guarantee you that you have converged. Yes?
We have to wait until they don't update.
Right. So you have to do a second iteration. If you are asked, like after the first iteration, do you need a second iteration? If you are asked this kind of question, you can say that since the centroid has updated, we need a second iteration to confirm that it is properly clustered. Okay? If after the second iteration your mu's are updated again, you need a third iteration. Okay? But if after some iteration the mu's are not updating, your centroids are fixed, then you can guarantee that it has converged. Is that part clear?
Sorry, could you say that last part again?
So if after some iteration of k-means clustering,
Mm-hmm.
if your centroids has updated, then you need another iteration to confirm that whether it converts or not. If they don't update, then you're sure that you are doing it great. So you are done.
Okay.
Bottom line, if your centroids update in a certain iteration, you need another iteration.
Okay.
If they don't update, then you don't need another iteration.
All right.
Okay, good? Yes.
So for the distance calculation, would you always use that same method or?
We will tell you. Read the question. Okay? Yeah. It will be three of any of the three. L1 distance, L2 distance, squared L2 distance. We will mention that one. This is an interesting problem from perceptron. Whether perceptron can separate non-linear decision boundaries, non-linear points. So here we are showing you 4 points, okay? And if you see carefully, this decision boundary is not linear. You cannot draw any linear decision boundary here. If you draw a decision boundary like this, you will misclassify some of the examples. If you draw a decision boundary like this, you will again misclassify some of the examples, right? So, one decision boundary can be like this, but perceptron cannot do that, right? And that is a problem. So to solve this problem, we can map the data from this space to another space where this can be linearly classified. Okay, so this is about representation. We are representing in two different axes, x1 and x2, and it seems like these things are not separable, right? But you can transform the representation space so that the data are linearly separable. Now, how can we do that? This is already mentioned in the question. We use a mapping function. So the mapping function is this. So you have a sample x, we give it to some mapping function, and that outputs a new sample. Okay, that corresponds to your. So the mapping is here. If you have a sample x has two elements, two-dimensional vectors, x1 and x2, give it to the mapping function. This will be z1 and z2, where z1 is basically multiplying x1 and x2. This is simple mapping. Multiply the values. That's it. And z2 here, multiply the values and take the negative term. Okay? This is simple mapping. So what does it mean? Let's say this is x1, we need to map it to z1, right? So z1 will be two-dimensional. Now it says you need to multiply the elements of x1. Okay? So the elements in x1 is 1 and 1, right? If you multiply them, it will be 1 times 1. Okay? 1. Is that part clear? We are taking x and using this formula here to map it to another space. Okay? So the formula says we need to multiply the elements in x, okay, and put it to the first element. So if we multiply 1 and put it here, it will be 1, right? And the second one says multiply the two elements but negate them, negate the result. Okay? So if you multiply 1 and 1, it will be 1, but you have to negate the result, so it will be negative 1. Is that part clear? Right? For this one, x2, it will be mapped to z2, right? It is again, the first entry is multiplying the two elements. So if you multiply 1 and negative 1, you will get negative 1. And for the second entry, you can multiply these two things, it is negative 1 and another negative from the equation here. So it will be positive 1. Is this clear? You can expect similar kind of question in the exam. So make sure you understand this thing. Yes. Yes. Everything will be. Like here, it is the mapping function, right? So in question, we will give you the mapping. Yes.
Is the mapping function used just some arbitrary thing used for the purposes?
So the mapping function is carefully designed so that your mapped samples like the z's can be linearly classified. You cannot take any, you can take any arbitrary function, but it will not give you any benefit, right? To get some benefits, you have to choose it carefully. For example, you will see why we are choosing this kind of thing. Mapping. So if you map this one to z3, it will be multiplying these two, right? So it will be negative 1 and 1, and x4 will be z4, that will be 1 and negative 1, right? So if you see now, z1 and z4 are basically the same thing, right? z1 and z4 are basically the same thing. And z2 and z3 are the same point, right? Now if we plot them, there should be a plot, no? Okay, let's plot them. x1 and x2. So z1 is basically 1, negative 1. So it will be 1 and negative 1 here. It will be z1 and z4, right? And z1 corresponds to x1 and z4 corresponds to x4. And for these two, it is negative 1, 1. z2 and z3 is negative 1, 1. So it is basically negative 1 and 1 here. So these are z2 and z3. They belong to x2 and x3. So now if you come back to the plot, you see x1 and x4 belong to the same class, right? And when we map them, they coincide on the same point, right? Similarly, x2 and x3 are from same class, and when you use this mapping function, they goes to the same point. Now the non-linear problem became linear, right? And you can easily solve it with a perceptron. So this is how mapping function can help you convert a non-linear function to a linear function that you can solve with perceptron. Clear? So there is no math in this math. This is basically mapping things, drawing things, right? The question is, find a linear classifier, right? The answer is, we found a linear classifier. That's it. Yes.
So where it says you can find out, try it.
Yes. Okay. So when we ask questions that looks complicated, they are generally easier than the question that looks like simple. For this question, if you read through like everything and bang your head on the desk, like what's going on, this is the simplest question, right? But from the very first look of it, it might seem very complicated. Just read it carefully and do things step by step. So if you can solve questions by plotting it on the paper, we will give you full points. Okay? Yes.
When it says like the bold x equals x parentheses 1, x parentheses 2, they're referring to the points like right above, right? The 1, 1, 1, negative 1?
Yeah.
Okay.
So when we say x1, this is pointing to a sample,
Mhm.
okay? And that is a vector of 2 dimension, 3 dimension, whatever that is.
Okay.
But when you say x bracket 1 or parenthesis 1, that is an element on that vector. Alright? So that is the difference. If
Okay.
you use subscript, that is the vector itself. But if you use parenthesis, that is one element inside the vector.
Okay.
Okay? Any question on this question? Now if they ask you to like provide us the value of W and B, from the plot you can see this goes through 1 and 1, right? 1 point. So you can say W is basically 1 negative 1, sorry. Yeah. 1 negative 1 B is equal to 0. So why so this is the decision boundary you have, right? We plot the decision boundary, but your actual W is perpendicular to the decision boundary, right? So that is why it is 1 minus 1 and B. But these values are not required, they did not ask you to write this. Just plot it and say we found the decision boundary here. Are we clear? Oh, I'm already out of time, so let's go over the third question quickly. So principal component analysis or PCA. We are given n images and
Right.
each of them are 2 by 2. Okay. So it has a condition. The condition is diagonally opposite pixels are the same value. Okay. So you can say that if the image is like this, it has x here, it will have x here. If it has y here, it will have y here. So diagonally opposite values are the same. Okay, this is the condition. The first question is how many principal components do we need to represent the image? How many? Any idea? Sorry. Number of rows means 2.
Yes.
Why does rows matter here? If we have 3 rows, then it will be 3. Okay, you think true. Anyone else who thinks 4 because it has 4 elements, not 2? So it would be 2 because it has 2 independent elements. Because we say diagonally pixels are the same. So basically they can be represented as one number, right? So we can say the degree of freedom along this diagonal is 1, right? So we need one axis along this line. And this one, another one. So it needs 2 principal components because there are 2 independent numbers, 2 degree of freedom, right? Whatever you can say. So to represent each image independently, you need 2 principal components. You don't need 4 things here. Now, suppose we are given the first principal component like this. Can you project a given image x, to this principal component that we are giving you? Okay. To solve this, you are asked to calculate this, where this would be minimized. Okay? So if you want to do this, you need to first calculate the alpha here. There is a little alpha here. You are given u1, right? You need alpha. You need a alpha that minimizes this part, right? So to calculate this, you need alpha equals xt u1 divided by u1. That is your equation. Now, the image is 2 dimensional, 2 by 2, right? To make your life easy, you can vectorize it. For example, this is u. You can calculate u1, you can vectorize it like this. 1, 0, 0, 1. Right? You can vectorize it. For images, you can vectorize this. X equals x11, x12, x21, x2. Right? We have simple linear vectors now. Clear? Now we can calculate xt, which is basically making it a row vector. And you are given u1, that is a column vector, right? And you can calculate the norm of u1, right? You will get alpha. That's it. So if you want to do this, so xt will be x11, x12, x21, x22, right? And then u is 1 over 2, then 1, 0, 0, 1. And this one, the norm of u is basically 1 over 2, 1 squared, 0 squared, 0 squared, 1 squared, right? That gives you alpha. So if you calculate this, you will get your alpha. And if you put this alpha here, put the alpha and you have the u1, that will give you your x hat. That is the question. Is this question clear? The second question is same.